Okay, so what we're going to do is we're going to have class for 23 more minutes, and then we'll hand out the tests. I gave the test yesterday, and everybody finished within the 45 minutes that was remaining, or 50 minutes, I guess. 50 minutes that was remaining. So this will be your easiest test that you have. Anyway, we'll get to that in a minute. So you should have watched the two videos, part of one video and then the entirety of the second video. And what we were talking about was this particular example where we had a universal set consisted of these letters and then two other sets that consisted of a selection of the letters that are in the universal set. And so we did some things like intersections and unions, and those are pretty straightforward when you only have two sets and just a single operation. But we did look at these two right here, which were a little more complicated, and you had to follow the order of operations that you would normally follow. So you do what's in parentheses first. If you have a complement, then you have to do that first. So we're going to do two more examples. So this is number 24, which is a subtraction process. So the best way to explain this is, there's a couple of ways to explain it. One is you look at set Y, which consists of the letters A, B, and C, and you subtract. When you subtract X, you remove the elements that are in set X from set Y. So if you look at set X, the ones that we have in common are A and C. We don't have a B here, we just have A and C. So when you subtract set X from set Y, we're going to remove A and C, and that will just leave one element, which is the letter B. So let's write it out so we can see it in one place. So we have Y as set A and C. Consists of three letters. Set X is A, C, E, G. And so what we're going to do is we're going to eliminate this one and this one because they're common. And so the final answer is the letter B. Okay, so that's how you would do it, just looking at the sets. This is an example of what you would do using a Venn diagram. So, and I haven't written all the letters, but let me go ahead and include all this. So we have A, B, C, D, E, F, G. I think it went up to H. No, didn't have H. So that would be a graphical representation of the sets that we're looking at. So set A consists of the letters A, B, and C. Set X consists of the letters A, C, E, and G. A and C are both in sets X and Y. So we have this overlap. So, and then D and F are not in either sets X or Y. Now the set Z, which I haven't included in here, but we're not worried about that right now. So for example, we'll talk about this more later. If you wanted to know what the intersection of these two sets, it would be the overlap. So the intersection of set X and set Y is going to be the set consisting of the letters A and C. If we said what's the union of these two, we'd say it's A, B, C, D, E, and G. So it's the letters that are in both sets, either one set or the other. If we said, what's the complement of Y? Well, that would be everything that's not in Y, but in the universal set. So Y prime would be D, E, G, and F. The complement of X would be B, D, and F, everything that's not in X. So now, speaking about subtraction, here is set Y. So what we're basically doing is eliminating the letters that are common to the two. So if you take set Y and you subtract off set X, you're getting rid of these two. And that leaves us with element B. We'll do more of this later, but for right now. Okay, here's another one of the more complicated arrangements. So what do you guys think would be the first thing that we would need to do in this multi-step process? Is it what's in the parentheses? Or do we need to do something that's already in the parentheses first? We know what set X is, because that's written on the other page. Yeah, so we need to do the complement of Y first. So that would be the first thing we do. So we take Y complement, which is the elements that are in the universal set, but not in set Y. So what are the letters that would be in the complement of Y? It'd be D, E, F, and G. Is that what you said? Yeah. Okay. So the complement of Y is D, E, F, G. Okay. So the next thing we do now, we do the stuff that's in the parentheses. So we're going to do X intersect Y prime. And you might be able to look back and forth, but I'm just going to go ahead and write them in. Write them in as a set. So we have A, C, E, G, which is set X, intersect with the complement of Y, which is D, E, F, G. So that ends up being a set. Everybody got that? See what I did? If you have any questions, stop me. So intersection is, what's another word for intersection? So let me go over here.
So this is class 6A, and the topic that I want you to respond to is to go into Google and check why it's called a Venn diagram. Who is Venn?
Here and show you this one. So this was the intersection. So it's the elements that are in both sets. So it's not, you can think of it, and it has to be in set X and in set Y prime, or you can think common. They have to be common to both. So Timber, what letters are in both of those two sets? E and G. Good. So that is the parentheses. Okay. You're squinting. I didn't know if it was too small or you just can't see. Oh, you forgot your glasses. Okay. Okay, so the last thing, we have one last thing to do, which is to take the union of this with the, well, we have to actually do Z prime first because we don't know what that is unless we've done it before. So before we can do the last step, we have to find out what the complement of Z is. So let me ask somebody, Katie Lee, what's the complement of Z? So it's the elements that are in set, the universal set, but not in set Z. A and G. Okay, so that's the complement of Z. And now we can do the final thing, which would be X intercept Y prime. What is it? Where am I here? Union Z prime. So you could compare this one with this one right here. Actually, those are the two we're comparing, but I'm just going to go ahead and write them out. So X intersect Y prime is the letters E and G, and that is in union with Z prime, which is A and G. So the union is where you have, they can be in either one or the other. So there are three letters. They are, Justin, what three letters should I put in the union of these two? So which letters are in this one or that one? G, there's definitely a G in there. Yeah, and Yep, there you go. Sounds like we're playing Wheel of Fortune, except it doesn't make any sense. Okay, and that's because we have A, E, and G in either one of them. So you just basically list all the ones that are in both sets, and don't repeat. You don't have to do G twice, because G is just once means it's in the set. Okay, so that's how those work. Make sure you know how to do them because you'll see them on the test. Okay, this one is, they have a couple of problems. I'm not going to test you on this, but we're going to just discuss what they're looking for. It says describe each set in words. And they don't want you to go left parenthesis A upside down U B prime or something like that. We got to come up with a description. And so you got to figure out how to use words to represent the grouping of the first bunch and the grouping of the second bunch, and then the operation between the two groups. So the operation between the two groups is which one? Either is it a intersection or a union? Union, because it's the U. Okay. So what we're going to say here I underlined it. Okay. So we're going to say the union. Okay. So that's the thing. We start out in the middle. It's kind of almost the opposite of the way that we would do the actual operations. If we knew what set A and set B were, we would normally take the complement of B and the complement of A. We'd have to do those first, but it wouldn't make sense to try to go that way. So we almost start from the last thing and then work our way in. So we would say the union, so I'm referring to this thing, of the set. So this is going to be a set, and this is going to be a set. So I'm going to say the set, which means this one because it's the first one, resulting from the intersection of sets A and the complement of set B. So that's what this says. So let's read it. So the union of the set resulting from the intersection of sets A and the complement of B. Then we have to get the second part. And the set, that's the second bit. The set resulting from the intersection of set B and the complement of set A. I didn't put set there, but I probably should have. So it takes a little thinking to try to figure out how to say that in the right order so that if I describe that, you'd be able to write it out. So it's tricky to do, so that's why I'm not testing you on it, but they did have it in the back of the chapter, so I figured I would at least talk about it. Okay, now you'll have some problems that are associated with this same example. And it's kind of like, I told you you use set theory in computer programs in terms of looking for common things that are the same. I don't know if I mentioned in this class or the other class, but if you went to Lowe's and you want to get a refrigerator that's a certain size with the stainless steel finish and the refrigerator, the freezer on the bottom, there's a whole bazillion choices these days for refrigerators, and you narrow it down because you want something. So there's an overlap. I want this, and I want this, and I want that. So in this case, it's the same kind of deal. We're talking about the symptom or the result of various bad habits here. So we have two bad habits: smoking, using tobacco, which are emphysema, heart damage, and cancer. There's probably more. I'm sure there's more, but we're going to just stick with 3. And you have the things associated with liver damage, or alcohol can give you liver damage, brain damage, or heart damage. And so rather than writing out, what we want to do is we want to come up with some mathematical way of representing this information. So the way we would do that is instead of saying tobacco, we would use a letter that represents tobacco. So we would say T, and rather than saying T, the effects of tobacco are emphysema, heart damage, and cancer, we would say T consists of the set of the letters E, H, and C, which in turn represent those 3 things that you can get from doing bad stuff like smoking tobacco. So that's the set of the problems. adverse effects, I guess that's what it's called. Then I'd use A for alcohol. So that's, I'm going to use a capital A because that's for set. And we list the letters representing the bad stuff. So L, B, H. Okay. So you can use that for your homework. You already know what to do. And then what they're asking you to do is then answer some questions relating to commonality or the complement, or whatever subtraction of sets. Now that we've defined the sets, then we can just use our normal, what we just did here, not this slide, but the previous slide. We did the various set operations. So here's two examples. So number 38 asks for the complement of A. Basically what that means is the symptoms or these adverse effects that are not associated with alcohol, but are associated with the other things that we're looking at. In this case, we're only looking at two things. So when you have a complement, you need to know what the universal set is, because the complement is the elements that are in this, not in the universal set, but not in the given set. So we need to list what is in the universal set. Well, in this case, the universal set just consists of all of the possible symptoms that we have here. So I'm going to do this in alphabetical order. So we've got brain damage, cancer, emphysema, heart damage, and liver damage. So that's our universal set. And so T is a subset of the universal set. A is a subset of the universal set. And I think I've got all this. Okay, so now to find the complement of A, all I have to do is look at the universal set and see what's in here but not in there. So you could, mark out the ones. You could start with the universal set and mark out the ones. So why don't you just do that as an example, the way you would find the complement. So the complement of A, what we do is we could list the universal set and then eliminate the ones that are in the set that we're looking at. So I can get rid of that one, and get rid of that one, and I can get rid of, what did I miss here? H, okay? If you just can do it looking at it, that's fine. I'm just giving another way of doing it. So the complement of A would be cancer and emphysema. Those are the two adverse effects that are associated with the other bad habit. We have the common one, which is H. So that gets eliminated. Okay, so that's how you do that. And then we have T union A. So again, we could just look at these two and write the answer. So let me ask somebody here. So Hayden, what is the set for the union of those two? Yeah, it actually would be this. That's what you were thinking, right? It's all the symptoms, because that's how I came up with the universal set. I basically took the union of these two things. So the union of these would be the universal set. If I did T intersect A, then that would be, let's see, who am I going to ask? Harley. So what's the intersection of sets T and A? Intersection means it's the elements that are in both sets. So what elements are in both sets? Just H, yeah, right. So you got some of those for homework. Pardon me? Say it again. Yeah, it'll be fine. Yeah, sure. Okay, the next one, they're asking you to look at this and answer the question whether this is always true or not always true. So not always true means if you can see one example where this is not true, then it's not always true. So it's either always true or not always true. Doesn't have to always be false. It just has to be two choices. So if you can think of one example where it's not true, then it's not always true. So look at that. So what this is saying is it says A is a, what does that stand for? You should know because it's on your test today. Subset. Yeah, so A is a subset of the intersection of A and B. So we'll take a poll here. So think about that. Is A always a subset of the intersection of A and B? How many people say it's, what was the question? Always. It's always true. Is that always true? Okay. That must mean that we have one person who's going to vote that way. How about it's not always true? Okay. So you guys, the second choice is correct because you can, one thing you can do is you can just make up an example and prove it's wrong. And if any example doesn't work, then it's not always true. So here's an example. I'm going to make one up very quickly. So if set A consists of the letters A and B, and set B consists of the letters C, well, actually, let's put B and C. So the intersection of A and B is going to be the letter B. So the question is the set A comma B a subset of that set? And the answer is no. If I did question, is A subset of the union of A and B, is that always true? And the answer is yes, because you can, well, you can't prove just by doing one example, you can't prove it's always true, but if you do the union of two things, the union is always going to have the elements that are in set A and then some more that might be in set B. So this is true. All you do when you do a union is just add more stuff on. And therefore, so that is always true. You have to answer that, you can't use a specific example because you could come up with a million examples and the millionth and first example will be wrong and then it wouldn't be true. So you can always prove it wrong with an example, but you can't prove it right. You have to kind of think about what's going on. Okay.